This is cin2103 week 10, transport layer, module 14. Okay. So in this chapter, we will learn about transport layer, the most famous TCP protocols, which is UDP and TCP. Okay, port numbers, and so on. So what is the function or role of transport layer? Transport layer is responsible for logical communication between applications running on different hosts. The link between the application layer and the lower layers that are responsible for network transmission. So you have, let's say you are running email from on one computer and it's communicating with the email server on another computer. The email will use a port number on your computer. And when it's communicating with the email server on the other side of the network, it will use another port number on that email server. And then they will communicate with each other using that port number. It's like the door. Only they will communicate using that port number. And if you have another application running on your computer, let's say HTTP. HTTP uses which port number? Very famous, 80. Okay, it's communicating with the HTTP server, also using port number. Who is responsible for this logical communication? Transport. Also, it will provide the communication between the application layer and the network layer because it's in the middle. Remember the TCP/IP model: application, transport, network. So transport provides the communication between application and network. Your application does not communicate directly with your network. It has to go through the transport. It tracks individual conversations. Conversations meaning the application instances that you are using. So if I am using Word, I am using Excel, I am using email. When I receive email back, it does not pop up on my Word. It will pop up on my email. Why? Because transport is organizing this. It uses different ports for different applications. Okay? Segmenting data and reassembling segments. It will divide it into different segments, and when they arrive, it will reassemble them. It will add header information. It will identify, separate, and manage multiple conversation. It will use segmentation and multiplexing to enable different communication conversations to be interleaved on the same network. So I have one cable, one media, and I have big bandwidth. So I don't need to have one cable for each network, for each communication. I will multiplex all the conversations from my inputs into one media, okay, using transport layer feature. IP, why we need TCP? Because if we rely on IP alone, like we studied before, IP is best effort. It does not guarantee delivery of your information. Okay. Transport layer protocols specify how to transfer messages between hosts and are responsible for managing reliability requirements of a conversation. The transport layer includes the TCP and UDP protocols. These are the most famous transport layer protocols, and we will study them in details, inshallah. TCP stands for Transmission Control Protocol. It provides reliability and flow control. Number and track data segments transmitted to a specific host from a specific application. Look here. The user is sending information. Okay. Information is divided into segments. They are sent over the network. So how do we make sure that they are delivered? None of them is damaged. The IP does not provide guarantee. Internet alone does not provide guarantee. You have to have another feature or another protocol to provide you with some sort of guarantee or reliability. Okay. And when the segments arrive at the destination, again, TCP will reassemble them because some of them might arrive before the other. And the order might be misordered. So it needs to order them accordingly. This is done by TCP. Here we are using FTP. Before I gave you another application, HTTP or email, the same concept. So it will number and track segments, acknowledge received data. Once it's received the segment, it will acknowledge. Received, send me the next one. Received, send me the next one. We call this acknowledgement. Retransmit any unacknowledged data. You sent something, but somehow it got corrupted, and you did not receive acknowledgement. You will wait for some time, and then if you don't receive acknowledgement, I will send it again. This is all controlled by TCP. I think we are beginning to like TCP, right? Good. Sequence data that might arrive in wrong order. Send data at an efficient rate that is acceptable by the receiver. So also it makes sure that the speed or the rate that the data is sent is acceptable by the receiver. Not the sender is very fast and the receiver is slow. Okay. The other protocol is UDP. UDP is unreliable, but it is fast. It is connectionless protocol. It will just send. Does not wait to establish connection and just sending. Okay. It is known as best effort delivery protocol because there is no acknowledgement that the data is received at the destination. Okay. So we have to use the right TCP protocol, the right transport layer protocol for the right application. So imagine with me, if for email, which one is better, TCP or UDP? For email, TCP, because you need it to be correct. You don't need your email words to be like for IP telephony. You need speed. No. UDP. Because even if you are talking with someone, one maybe millisecond it's all right. You can control this with the quality of service. So for IP telephony, it's UDP. For YouTube, most of the time it's UDP. Most of the time. But okay, so here it is important that all the data arrives at that it can be processed in its proper sequence. Okay. So here they gave you TCP examples, email, SMTP and map, IMAP, and browser. Okay. You want to browse Cisco, you need really correct information. You don't want wrong information displayed. For UDP, we have two examples, VoIP and DNS. Okay. But please don't get confused. The HTTP by itself, is this an application layer protocol or transport layer protocol? application. But it relies on which protocol in the transport layer? TCP. So don't confuse you, please. Remember that. Okay. DNS also is an application. VoIP is an application. So again, we will talk more in details about TCP. It will establish a session because it's a connection-oriented protocol. Before they start communicating, they need to agree, the sender and you receiver, they need to agree on a connection, permanent connection or session between source and destination. Before they start forwarding, the sender and receiver, they agree, okay, we will use this session to start communicating. It's very organized. It will ensure reliable delivery, okay? Because sometimes a segment becomes corrupt or lost. So you need to retransmit this segment. Also, it provides same order delivery, okay? It will reassemble the data when it arrives, the segments. It will also support flow control, which we just mentioned before. Make sure that the sender and the receiver, they have agreement on the rate. They're not going very fast or very, okay? You see the TCP header, because of its so many functions, it is heavy. You see the header of TCP, how much information there? When we compare it with UDP header is much smaller. Look at the TCP header. It has source port, destination port, sequence number, acknowledgement number, header length, okay, reserved. Here also control bits, window, and urgent. See urgent? And the size of this is 20 bytes. These are the TCP headers. We have talked about some of them already, so please spend 1-2 minutes looking at them, please. We already talked about the source port, destination port. It's a 16-bit field, and we have some common port numbers. You need to know them, please. For example, for HTTP, it is 80. We have the window size also. We have checksum for error checking. Urgent, wow, beautiful. If some data is urgent, it will flag for urgent delivery and so on. Any questions about this part? Okay. These are the applications that rely on TCP. Thank you. FTP, HTTP, SSH, SMTP. They rely on TCP because it provides them with reliability, okay, and control, data flow control, and recording segments. UDP, on the other side, data is reconstructed in the order that it is received. Any segments that are lost are not resent. There is no session establishment. The sending is not informed about resource availability. So I'm just sending. I don't know what's the case at the receiver. You see the header of the UDP much smaller. See, only has source, destination port, the length, and checksum. There it was 20 bytes. Here it's only 8 bytes. Remember, here it was 20 bytes. This part, the header. Here it is. That's why it's very fast compared to TCP. 8 bytes only. These are some common UDP port numbers. This is, by the way, what's included there: source port, destination port. We already explained that. Applications that uses UDP we have. Okay. So let us stop here and then we'll continue.